What if I told you that a single aircraft is about to completely reshape how we think about international travel? That right now, airlines around the world are placing massive orders for a plane that promises to make direct flights possible between cities that have never been connected before. The Airbus A321XLR isn't just another new aircraft. It's a strategic weapon that's forcing the entire aviation industry to reconsider everything they thought they knew about long-haul flight economics. But why is this particular aircraft causing such a stir across boardrooms from New York to Singapore? And what makes it the most strategically significant commercial aircraft of the decade? To understand the A321XLR's significance, we need to step back and look at how long-haul aviation has evolved. In the early days of commercial aviation, airlines had no choice but to use narrow-body aircraft for transatlantic flights. These planes were cramped, loud, and required frequent fuel stops. The introduction of wide-body jets in the 1970s changed everything. Aircraft like the Boeing 747 and later the 777 and A350 could carry hundreds of passengers across oceans in comfort, while their large cargo holds generated additional revenue. For decades, this became the standard model. If you wanted to fly long distances, you needed a big plane. But this model came with a fundamental limitation. Wide-body aircraft are expensive to operate and require high passenger loads to be profitable. This meant airlines could only justify direct flights between major cities with sufficient demand. Smaller cities were left out, forcing passengers to connect through crowded hub airports. The hub-and-spoke system became dominant not because it was convenient for passengers, but because it was the only way to make the economics work with the available aircraft technology. Have you ever wondered why airlines are so obsessed with fuel efficiency? Fuel typically represents 28 to 32% of an airline's operating costs, according to IATA data, making it the single largest expense after labor. The percentage varies by region, from 25.5% in North America to 36.3% in Latin America, with global projections showing fuel costs representing around 32% of airline spending in 2024. Every percentage point of improvement in fuel efficiency directly translates to millions in savings across a fleet. But here's where it gets interesting. The A321XLR doesn't just offer modest improvements. It delivers 30% better fuel efficiency compared to previous generation aircraft and achieves up to 45% lower trip costs than modern wide-bodies. These aren't incremental gains. These are the kind of numbers that force airline executives to completely reconsider their route networks. The secret behind the A321XLR's capabilities lies in one critical innovation: the rear center tank, or RCT. This isn't just a bigger fuel tank bolted onto an existing design. It's a complete reimagining of aircraft fuel management that required 5 years of development and created entirely new certification challenges. The RCT is permanently integrated into fuselage sections 15 and 17, positioned behind the main landing gear bay. This 12,900-litre tank holds more fuel than several optional tanks from previous A321 variants combined. But here's the brilliant part. Unlike previous long-range narrow-bodies that sacrificed cargo space for fuel, the RCT design preserves the aircraft's freight capacity. Premium Aerotech in Augsburg, Germany, manufactures these complex tank structures through advanced assembly processes that required completely new supply chain innovations. Each tank undergoes rigorous testing before delivery to Airbus's Hamburg facility, where it's integrated into the aircraft structure. The engineering challenges were immense. The increased fuel capacity pushed the aircraft's maximum takeoff weight to 101 metric tons, requiring structural reinforcements throughout the airframe. Fire safety modifications added protective liners and additional structural elements, contributing 700 to 800 kilograms to the aircraft's weight. The A321XLR's innovative design created a unique problem. Existing aviation regulations weren't written to cover this type of aircraft. The European Aviation Safety Agency had to establish special conditions to address gaps in standard airworthiness regulations, specifically for the aircraft's unusual fuel tank configuration. This wasn't just bureaucratic paperwork. The certification process revealed real engineering challenges that had to be solved. The RCT's design fell outside the scope of traditional CS25 certification specifications for large commercial aircraft, requiring new safety standards and testing procedures. The regulatory framework demanded extensive fire safety modifications and additional structural reinforcements. EASA's special conditions specifically required a new protective liner for the rear fuel tank and additional structural elements to address the novel tank configuration that fell outside standard CS25 certification specifications. These safety improvements added approximately 700 to 800 kilograms to the aircraft's weight, reducing maximum range by approximately 200 nautical miles from theoretical maximum to around 4,700 nautical miles under operational conditions. Both the FAA and EASA had to certify the aircraft separately. EASA certification for the A321XLR with CFM engines was achieved on July 19, 2024, followed by FAA certification on October 2, 2024. The Pratt & Whitney engine variant certification has been delayed to 2025. This dual certification process demonstrates the aircraft's compliance with both European and American safety standards, enabling global market deployment. But here's where the story gets really interesting, and where we start to see the true strategic implications of this aircraft. The A321XLR's economic advantages extend across multiple operational dimensions, creating a perfect storm of cost savings that airlines simply cannot ignore. Trip costs run up to 45% lower than current generation widebodies, while fuel burn shows a 15% improvement over the previous A321LR. Maintenance costs decrease by 25% through fleet commonality, enhanced by reduced crew training costs thanks to common type rating with existing A320 family aircraft. The aircraft's narrow-body configuration provides an inherent 20% economic advantage over wide-bodies due to its 6:1 seat-to-aisle ratio compared to wide-bodies' 5:1 ratio. This efficiency gain becomes amplified when airlines can maintain similar load factors while deploying smaller capacity aircraft on previously unprofitable routes. But there's a crucial threshold airlines must meet. For A321XLR routes to achieve profitability, passenger load factors must typically exceed 75 to 80%, depending on route characteristics and fare structures. The aircraft requires approximately 150 to 180 regular passengers on each return flight to maintain economic viability. This makes the A321XLR ideal for hub-to-secondary airport operations, rather than pure point-to-point services between smaller cities. Industry analyses show the aircraft requires load factors of 75 to 80% for profitability, needing approximately 150 to 180 regular passengers on each return flight to maintain economic viability. The economic model becomes particularly compelling when compared to wide-body operations on thin routes, where airlines struggle to fill larger aircraft consistently. The A321XLR enables sophisticated hybrid network strategies that bridge traditional hub-and-spoke and point-to-point models. Airlines are approaching this aircraft very differently, depending on their business models. Legacy carriers like Iberia are implementing precise timing strategies, coordinating A321XLR operations with existing wide-body services to optimize hub connectivity while serving secondary markets. American Airlines deployment from Philadelphia targets European secondary markets while maintaining crucial hub feed operations. They're not abandoning their hub strategy, they're making it more precise and efficient. Low-cost carriers are taking a different approach entirely. Wizz Air, building on successful 6-hour sector experience to destinations like Dubai, is using 47 A321XLR orders to push their point-to-point model even further, while preserving ultra-low-cost operations. They see the aircraft as a way to extend their successful formula to longer sectors without fundamentally changing their operational philosophy. The aircraft's 4,700 nautical mile range unlocks previously uneconomical direct routes between smaller city pairs, eliminating connection requirements and reducing total travel time. Direct flights often provide significant fuel savings compared to two-leg journeys by eliminating the descent, landing, taxi, takeoff, climb cycles and reducing total flight distance. However, there's a strategic challenge lurking here. Slot-constrained hub airports may penalize smaller capacity A321XLR operations in favor of larger aircraft to maximize revenue per slot. This creates complex strategic implications for network planning, as airlines must balance operational efficiency against airport capacity constraints. Boeing faces a significant strategic challenge from the A321XLR's market success. With no direct competitor currently in production, the company previously studied a new mid-size airplane dubbed the 797, designed as a clean sheet aircraft with 220 to 275 passenger capacity and a 4,500 to 5,000 nautical mile range. Boeing's plans for this aircraft were shelved in 2020 due to 737 MAX issues and pandemic impacts. The company has since explored various responses, including updated 757X, 767X, or 787-3 variants, but faces the challenge of developing new aircraft while addressing current operational issues. Recent reports indicate Boeing is testing supplier waters for a new aircraft study to compete directly with the A321XLR. But here's the critical timing issue. Even if Boeing launched a competitor program today, it wouldn't enter service until the early 2030s, giving Airbus nearly a decade of market exclusivity. During this time, Airbus will establish deep customer relationships and operational expertise that will be extremely difficult to dislodge. Other potential competitors face even steeper challenges. Comac's C919 offers limited competition with its 3,000 nautical mile range and 156 to 168 passenger capacity, significantly below A321XLR specifications. While Comac has announced plans for variants similar to Boeing and Airbus strategies, the C919's current capabilities position it more as a regional narrow-body than a true long-range competitor. But here's the question that keeps airline executives awake at night. How do you balance the A321XLR's economic advantages with passenger comfort on flights that can last up to 8 to 9 hours? The aircraft's narrow-body configuration presents unique challenges for long-haul passenger comfort compared to wide-body alternatives. Airlines must balance high-density seating configurations to maintain economic viability while providing acceptable comfort levels for extended flights. Cabin configuration strategies vary dramatically between carrier types. Low-cost carriers may deploy single-class layouts with up to 244 passengers to maximize revenue potential, essentially treating these as very long medium-haul flights. Full-service airlines implement premium economy and business class configurations with lie-flat seats, reducing passenger count but increasing yield per passenger. The A321XLR operates at 0.78 cruise speeds, approximately 5 to 10% slower than modern wide-bodies. This speed differential increases flight times by up to 1 hour on the aircraft's longest routes, impacting time-based operating costs and potentially reducing network efficiency in congested airspace. Airlines are approaching this challenge in fascinating ways. Some are betting that passengers will accept slightly reduced comfort in exchange for direct flights and lower fares. Others are investing in premium cabin configurations that maintain comfort standards while targeting business travelers who value time savings over space. The aviation industry's commitment to net zero CO2 emissions by 2050 positions the A321XLR as a crucial technology for achieving efficiency targets. The aircraft's improved fuel efficiency compounds the benefits of sustainable aviation fuel, as lower overall fuel consumption reduces both conventional emissions and SAF requirements. Sustainable aviation fuel integration can reduce aircraft emissions by up to 80% compared to conventional jet fuel. With the International Air Transport Association estimating SAF could contribute approximately 65% of emission reductions needed for net zero goals. The A321XLR's improved fuel efficiency compounds these environmental benefits, as lower overall fuel consumption reduces both conventional emissions and SAF requirements. The A321XLR's fuel system compatibility with various SAF blends enables airlines to adopt sustainable fuels as supply chains mature, supporting industry decarbonization goals without requiring aircraft modifications. However, a comprehensive life cycle assessment must consider manufacturing emissions, operational efficiency across various flight profiles, and end-of-life disposal impacts. Current SAF production capacity remains insufficient to meet growing aviation demands, requiring massive production scaling throughout the 20s. The A321XLR's efficiency gains help bridge this gap by reducing overall fuel requirements, while the industry builds sustainable fuel infrastructure. The A321XLR's success depends heavily on supply chain maturity and manufacturing capability expansion. Recent supply chain delays have impacted delivery schedules for airlines like American Airlines, highlighting the complexity of scaling production for specialized components like the RCT. Premium Aerotech's role in RCT manufacturing represents a critical supply chain node, requiring continued investment in production capacity and quality systems. Drawing on their experience with complex aerospace manufacturing, including Eurofighter components, Premium Aerotech developed specialized assembly processes for the RCT's intricate structural requirements. As order volumes increase, supply chain resilience becomes essential for maintaining delivery schedules and aircraft performance standards. The manufacturing complexity extends beyond the RCT to include specialized systems integration, advanced materials processing, and quality assurance protocols that didn't exist for previous aircraft variants. Each A321XLR requires more specialized manufacturing steps than standard narrow bodies, creating potential bottlenecks in the production system. Airlines are having to adjust their fleet planning timelines to account for these manufacturing realities, with some pushing back route launches due to delivery delays. The A321XLR's market entry marks the beginning of a fundamental transformation in narrow-body long-haul operations. Airlines will increasingly deploy the aircraft on routes traditionally served by wide bodies, creating frequency competition that pressures yields and forces network optimization across the industry. This transformation extends beyond individual airline strategies to reshape airport operations, maintenance requirements, and infrastructure planning. Secondary airports that never handled long-haul international flights are investing in customs facilities, ground handling equipment, and passenger amenities to accommodate A321XLR operations. The aircraft's success validates the narrow-body long-haul concept, likely spurring additional technological development and competitive responses that will further accelerate evolution in this market segment. We're likely to see improvements in passenger comfort systems, more efficient engines, and potentially even longer range variants as the technology matures. Airlines are also discovering unexpected operational benefits. The A321XLR's flexibility allows them to test new routes with lower risk, as the smaller capacity reduces the financial penalty of underperforming routes. This is leading to more experimental route development and potentially more direct connections between previously unserved city pairs. The competitive dynamics are equally fascinating. Legacy carriers are using the A321XLR to compete with low-cost carriers on their own terms, offering direct flights with lower costs per seat. Low-cost carriers are pushing into markets previously dominated by legacy carriers, using their cost advantages amplified by the A321XLR's economics. The A321XLR has now transitioned from concept to operational reality. Iberia received the first production aircraft on October 30, 2024, and launched commercial service on November 6, 2024, with a flight from Madrid to Paris. This inaugural service represents more than a symbolic milestone. It validates years of development work and begins the practical demonstration of the aircraft's capabilities. Iberia's route selection for the first commercial flight was strategic, choosing a well-established European corridor to prove operational reliability before expanding to longer-range destinations. The airline plans to deploy the aircraft on transatlantic routes to Boston and other secondary markets, demonstrating the hub-to-secondary airport strategy that many carriers will adopt. Early operational data from these first flights will be crucial for other airlines planning their A321XLR deployments, providing real-world validation of fuel consumption, passenger acceptance, and operational efficiency claims. What we're witnessing with the A321XLR isn't just the introduction of a new aircraft type, it's a fundamental shift in how airlines think about capacity deployment, route development, and competitive strategy. The aircraft forces a recalculation of hub-and-spoke versus point-to-point economics. Routes that were previously impossible due to aircraft economics are now viable. Secondary cities that relied on connections through major hubs can now receive direct international service. Airport authorities are scrambling to understand the implications. Some secondary airports see opportunities for international growth they never had before. Major hub airports worry about losing connecting traffic as passengers opt for direct flights on A321XLRs. The aircraft also creates new competitive battlegrounds. Airlines can now compete on routes they couldn't serve before, or serve existing routes with better economics. This is forcing network optimization across the industry and changing how airlines evaluate market opportunities. The Airbus A321XLR represents more than an aircraft upgrade. It embodies a paradigm shift toward precise capacity deployment, operational flexibility, and economic efficiency that will define the future of commercial aviation network planning and airline business models. As airlines take delivery of their A321XLR aircraft over the coming years, passengers will see new direct routes appearing on booking websites. Cities that never had direct international connections will suddenly be linked to global networks. The traditional model of connecting through major hubs will face competition from direct flights that are both more convenient and potentially less expensive. The aircraft's influence will extend far beyond its technical specifications to fundamentally alter how airlines approach route development, fleet planning, and competitive strategy in an increasingly dynamic market environment. The A321XLR isn't just changing aviation economics. It's rewriting the rules of how we connect the world, one direct route at a time. And that transformation is just beginning.